In the past, standard server architectures comprise single applications running on an operating system installed on a single bare metal server. Although it provides for great stability, this approach is not very cost efficient. Over time, growth in the number of applications greatly expands the number of servers in the data center. In order to become more cost efficient and get a better return on investment out of their servers, companies turned to server virtualization. Server virtualization is abstracting the operating system and application from the physical hardware. In IT terms, virtualization is a procedure or technique that abstracts those physical resources from the services that they provide. In server virtualization, a layer is added between the server hardware and the operating system or systems that are installed in addition to the hardware. This strategy has several benefits. For instance, it gives you hardware independence and flexibility. In the past, if we had an application fail, we had to find the exact same hardware configuration with the exact same type of storage, and we might even have to move NICs from the old server to the new server. In this case, because we have abstracted the hardware, we can move the applications and operating systems from server to server without the virtual server being the wiser. As a matter of fact, these virtualized instances run in parallel on a single server, and to each one of these instances they think that they are all running on individual servers when they're actually all running together on one. Server virtualization allows you to run multiple operating systems on one physical server. This feature can be useful in a testing or production environments. For example, you can copy a production virtual operating system and then practice upgrade procedures on it. This strategy ensures that you can use an environment that is the same as production without making mistakes that affect production users. After you have thoroughly tested the upgrade or changes and know the potential consequences, you can then go ahead and move those changes into production. This method of server consolidation provides a great reduction in costs and increased utilization on the physical hardware. For instance, in my environment, I might have a bare metal server, such as an email server, that is running at 20%. I might have a web server that's running at 40%, and a database server that's running at 10%. Instead of having all of those stranded resources on 3 separate servers, I can combine those virtual servers on a single set of hardware that allows me to share physical resources and drives the utilization up of my server hardware to 70%. This way I get a better return on investment on my equipment. There are several types of virtualization available. For instance, there's full virtualization. Complete simulation of a hardware environment allows unmodified operating systems to run within virtualized sandboxes. There are 2 types of full virtualization: host operating system based virtualization and bare metal virtualization. There is partial virtualization when some, but not all of the hardware environment is simulated. Certain guest software might need to be modified to run in this environment. There is also para-virtualization. In this instance, there is no simulation of the hardware, and it requires substantial modification of guest operating systems so that they can be installed in different virtual domains on one server. The abstraction layer that sits between the operating system and the hardware is typically referred to as a hypervisor. This layer is like an operating system, but is not intended for installation of applications. Rather, the hypervisor supports installation of multiple types of operating systems. The hypervisor itself performs multiple tasks. It provides resources to individual operating systems. It uses the resources of the physical server or the host on which it is installed to provide smaller or greater chunks to the operating systems or virtual machines that are installed on it. It provides connectivity between the individual VMs as well as between the VMs and the outside world. It also ensures separation between the individual virtual machines. Host operating system based virtualization requires a PC or a server. Now, in full virtualization, if you'll remember, there are two types. Host operating system based virtualization that requires a PC or a server that already has an operating system installed, such as Microsoft Windows or Linux environment. In addition to the operating system, a virtualized application is installed. Within that application, virtual machines are deployed. An example of this would be VMware Fusion. The second type, bare metal virtualization, means that the virtualization logic acts as its own mini operating system. Virtual machines are installed in addition to that mini operating system. This method minimizes the amount of resources that are unavailable to the VMs. Also, this method avoids potential bugs and security vulnerabilities of the host operating system. Now that we covered the hypervisor, let's talk about the definition of a virtual machine. A virtual machine is a logical container that holds all the resources that an operating system requires for normal operation. Components such as graphics adapters, memories, processors, and networking are present. As far as the operating system in the VM is concerned, there is no difference between the virtualized components and components in a physical PC or a server. The difference is that these components are not physically present, but rather virtualized representation of host resources. The operating system is the guest operating system. And in these situations, the guest operating system does not have full control over the hardware, but instead, those resources are assigned by the hypervisor. Applications are isolated from one another, and per VM, you assign virtual NICs, virtual MAC addresses, virtual IP addresses, memory, CPU, and storage space. Please join me for the next lesson, examining the Nexus 1000V.